Here we go. Let's get started on 5.1, which is an introduction to something called quadratic functions. We're going to be just dealing with only quadratic functions this whole unit and all that happens with quadratic functions. By the end of this lesson, I am hoping that you can identify and graph quadratic functions, as well as multiply linear binomials to produce a quadratic expression. That's my goal by the end of this. So let's just kind of get into it. Let's define what a quadratic function is all about. Well, a quadratic function is any function that can be written in a specific form. This is the standard form for it. A quadratic function can be written in this form. F of x is equal to ax squared plus bx plus c. So ax squared plus bx plus c. If it can be written in that form, then you know it's a quadratic function. But here's the key thing. This a cannot be 0. Let me get rid of that. Can't be 0, okay? So if the a is 0, then it's not a quadratic function. So that's what we're going to be looking for. And let's just kind of take some time. Let's take a look at what quadratic functions kind of look like. So what does a quadratic function look like? Well, here are two examples. Here's one, and here's another one. And we're just going to kind of talk about these two examples right here. These two quadratic functions, notice kind of bowl shape, right? This bowl looks like it's upside down right here, while this bowl looks like it's right side up right there. So let's talk about both of these situations. First off, let's look at this left one right here. The question right here is, does the quadratic function open up or down? Well, if it's upside down like this one, it opens downward. Okay, so this is a downward. Think of a bowl upside down, so it opens down. And this one right here, because it's like a normal shaped bowl, it's the right side up, it opens upward. Right there, okay? The next question asks is, what is the vertex of a quadratic function? Well, the vertex is either at the top of the mountain or the bottom of the valley, okay? So if we were to look at this, where is it? Well, this looks like it's a mountain, so we need to find the top of this mountain right here. And if you're climbing up the mountain, climbing up the mountain, when are you at the top of the mountain? Well, right here. So here's your vertex for that one. In this situation, the vertex looks like it's -1, 3. So our vertex is -1, 3. We could put that right here. The vertex is -1, 3. Maybe put like a little note. Vertex. Vertex, because I can spell it. There's a vertex right there. And here, look at this one. The vertex of this one is at the bottom of the valley. So if you're walking down the hill, when are you at the bottom of the valley? Right here at this point. This point is at, what does that look like? -1, -2. So we got -1, -2. That's this vertex. Right there. And the next question asks, we found the vertex. Yes, is the vertex a maximum or a minimum? Well, let's look at this one. Is that a max on this function? Is it the highest point on the function or the lowest point? Well, to me, that's a max right there. That's the highest point on the function. So it's the maximum. And I just wanted you to notice that the vertex on a downward function or quadratic that opens downward will give you a maximum. And one that opens upward, like this one, the vertex will give you a minimum. So that's just kind of a quick introduction to what these quadratic functions look like and some little ideas and properties of them. In this next section, we're going to show that a function is a quadratic function by writing it in quadratic form. So we got this form. We got to show that it's a quadratic function by writing it in this form. If we can get it in that form, we know it's a quadratic function.